Hi, this video is about how to build custom AI solutions. My name is David Hood, and I'm the CEO of 42 Robots AI, where we help organizations implement AI so that their competitors don't leave them behind. So I'll put a few links to a few videos. This is the compilation of several videos, how to identify AI opportunities, and then also bad solution architecture. And then there's another video embedded in here. Definitely recommend you watch those, if not first, at least afterwards, to kind of help. Well, there's a little bit of overlap that we'll cover there. I think it'll go expand on certain issues that are directly relevant to why this is so hard for people to do right now in organizations. They don't really even know where to start. So part of the challenge is that they don't really, there's unlimited opportunities out there. Basically large language models, which that's really what I mean with regards to AI in terms of that's what's new. There's been all sorts of AI for quite some time, and the real recent development is large language models. And really this is so, large language models are so broadly applicable to knowledge work that just about all businesses and all business processes within those businesses are poised to be affected in terms of being enabled to be more productive and more effective and be able to do more, automate more, and I'll talk a little bit more about that. And this is just kind of the giant elephant in the room. At a lot of organizations, it's not well understood, but it's well known that, hey, AI actually is going to have a huge impact. However, it's not understood, like, where do you even start? And there's a lot of talking heads out there, hand waving in ways that are not really incredibly helpful. Now, there are a few nerds that I've talked to who are actually building real world solutions, and they agree with when I lay out the case for how to actually do this. They're like, yeah, that actually sounds right. And I haven't really seen anybody talk about it in the way that I'm going to talk about it in here. But they all know that this part of this process. Hopefully, you understand that it's not an overnight process. As an organization, you need to start building the muscle for this, because if you do not and your competitors do, you will be left behind. So I would suggest starting with the lowest hanging fruit. And this isn't necessarily finding the things that you think add the most value to your organization, so much as it has to do with finding the things where you can get any amount of wins at all. So prioritizing the speed, cost, and ease of implementation or execution over the total value. Obviously, there needs to be some amount of value, or else what's the point? Because there are a lot of kind of like fluffy, impractical ways that you can use AI that don't really add any value to the organization, and that's to be expected. That you'll do some processes where that will happen, especially with your first few attempts at trying to implement AI. So try to shoot for something that has lower cost, just in case there's some part of the process that makes it so that even though AI kind of does something interesting, it doesn't actually help the process. There's going to be a lot of stuff like that. And this is also even for somebody who has a lot of experience building AI. It's sometimes a little bit hard to estimate this speed, cost, and ease, because it doesn't just have to do with like the AI solution itself. It's how does it fit within the business, and it's going to be very challenging to find somebody who both understands how AI works. Not both. There's multiple pieces here. Understands how AI works. Understands how to use AI. These are two different skill sets. Understands business systems in general and how that kind of affects the systems, and then fourth, how your business systems actually are affected. So they have to understand not just AI, but also your business and how it's going to affect things. And this is going to be extremely challenging to find somebody who's. I don't think you're really going to. It's practical to find anybody who has these all like knocked out 100%. And so you do expect a certain amount of error, but you kind of have to go through it. And getting any amount of wins, even something small, can help snowball this process and make it so that as an organization, you keep building that muscle. It's a very key part here when building custom solutions. All right, let's dig into AI engineering. So I do have a video called, The Real AI Engineer, Please Stand Up. Highly recommend that because I do see a lot of people calling themselves AI engineers, and I don't think they are, at least in my opinion. And part of this, I think, comes down to when I show you the simple diagrams here in a minute. They're going about trying to solve the wrong problems in the wrong way, and they're getting poor results as a result. And I think this makes sense. This is a very new technology, and it's a lot of people just don't have the experience, or maybe it's the creativity, because there's very novel ways to use technology that you couldn't do before, or there's also just kind of like a very rigid kind of groupthink going on in a large portion of the tech industry. And so it's not necessarily somebody's fault, or I'm not making a value judgment on that person as a human, other than to the extent that I don't think that there's very many real AI engineers out there. Highly recommend Python. It's not required, but this is the most common language. This is what all the machine learning engineers use. This is best for like data processing. It's as far as I can tell, it's a very readable language. Now I've coded in a lot of kind of back-end languages that deal with data, and so it just immediately made sense to me when I started to learn it. And within just a few days, I was able to really actually start to write effective Python code. So this is, if you have a back-end coder and they don't use Python, and you want to try to make them an AI engineer, then I think kind of moving them into Python shouldn't be too challenging. But maybe that's my experiences and not everybody else's. And then you need somebody who actually uses LLM APIs. So they need to have experience actually calling large language models in code and doing stuff with that. So doing the prep work and making the call and doing the post work, even for very simple scripts, you'd be surprised at how few people actually have tried to solve problems this way. And then a key understanding here is using the LLMs as tools, having the software use the LLMs as tools, as opposed to the other way around. And that'll make a little more sense when I show you the diagrams. And really what you want to do is you want to pull as much out of the solution out of the LLMs instead of putting as much as you can in. This is one of the biggest things that I see in the tech industry right now. Everybody's trying to solve, maybe not everybody, just about everybody is trying to solve everybody by, let's make the model the solution, and let's make it as effective as possible, and let's shove as much of the solution into one model as possible. And I think the data, or at least my R&D, has shown pretty consistently that this is suboptimal for most use cases. Yet everyone seems to be trying to do this, and you can tell almost every single piece of content I see, even from machine learning engineers, even from people who I think should know better, mention the product is the model and the model is the product. And that is not going to cut it. That's just not going to cut it. And I think this will become more and more obvious over time as real world solutions are built the correct way, which I'm going to show in just a minute. You also want to triage processes. Again, this will go back to, let's just, I'll go into a second. This goes back to thinking about this actually from a more classic software standpoint than it is from we need to design the architecture around the LLMs. No, you want to be able to kind of fork the design. Sometimes it goes here, or fork the architecture and the flow of a certain process. And then thinking about this not in terms of you got a one shot to process the data, and then you put it into the model and you get the result out the end. There's a lot of times where you parse the data into 3 parts, and each one gets processed individually. You put them back, maybe you pull in some other ones. You go through an LLM, you do some more data processing. There's a whole lot of multi-step process here that really enables you to take these solutions to another level. And obviously you need to do regular model and prompt testing. So model testing is where the capabilities of these models is evolving. I don't think it's evolving quite as quickly as people think. Basically, from nothing to ChatGPT, or let's say GPT-2 to GPT-3, which was GPT-3 is ChatGPT, huge difference. GPT-3 to GPT-4, very large difference. And then since GPT-4 came out in, I think it was April of 2023, I wouldn't say the models have gotten way better. They definitely have gotten better, and right now, as of August 2024, generally Claude 3.5 Sonnet is the best model, but sometimes I still like GPT-4 better, and there's some testing for some other models for specific use cases where other models are better. I wouldn't really trust too much the kind of testing metrics in there, and you see these leaderboards because it's easy to game the test. Probably the most accurate one is the one where it's completely human evaluated. I believe it's called Model Arena. Chatbot Arena. So you can find this on Hugging Face. So right now GPT-4.0 the latest is at the top there. And so this is probably the best metric. Even this probably isn't perfect because who's actually doing this? There's probably not a scientific sample of who is actually implementing this in the use cases they're using. Also, these scores are so close to where like it's all roughly the same, similar. A lot of times I'll put something in Claude and GPT-4 and I'll get a very similar result. However, when we go in and we're trying to solve, let's say, a problem for a client, oftentimes for very specific things, there is a massive difference. So you need to be able to test the model and then also the prompt as well. And they both kind of need to be tested somewhat independently and cross-listed. You know, so the right prompt for one model might not be the right prompt for another model. And then the prompt testing, there's a wide variety of ways to do this. Technically, there's unlimited ways to go about doing this, and there's a variety of different prompt engineering tools. I recommend trying some of those, although we just kind of built ours from scratch internally, and that tends to work pretty well, especially as you have somebody who's done this more and more. You don't necessarily need like fancy tools. You just kind of understand some of the frameworks that are needed to get this to work really well. I mean, really one of the most important things and most that you need to do is have reliable model outputs. This is key to AI engineering, just about any process. And this is part of why when you try to shove everything in the model, you just don't get as much a reliable output. You need to really kind of pick the problem apart. And then it definitely needs to be integrated into your processes, into the data and all that stuff, all that jazz. Okay, so let's just kind of recap real quick what a bad solution diagram is. This is what I see most people proposing and what I've seen most of the time, and I think this is why they're struggling. Basically, they have training, be it training a model from scratch, doing a big fine-tuning, doing a mini fine-tuning, and I guess maybe we change this. This is probably should more be prompt engineering as well instead of the training. And then they put the LLM, they find like their best LLM that they think to solve their problem, and then they kind of put it on a loop. And they use tools, which is essentially what I would call classic coding. So whatever you could do with classic coding, they say, oh, the model itself needs to use the tool to solve the problem, or to grab some new information, or to push some information. This is a bad solution architecture. It just is. You're gonna have a lot of trouble solving just about any problem of any sophistication, especially, and this is especially what you find within companies. You find complex problems that a single LLM on a loop with some tools and some training and some prompt engineering is going to really struggle to give you reliable quality outputs. I bet what you can do with this, the part of the problem with this is that you can get some good outputs sometimes. And so a lot of times you kind of start and you get like you get some false positive signs, but you get to where it's like, okay, this works like 65% of the time, and we just can't get it to do any more than that. That's a lot of times what will happen. All right, here is good. So this is a very simple drawing of a simple architecture. This is just kind of classic software development. Something comes in, you have an LLM that processes a key step, and maybe it helps triage, and it goes here. And if it goes here, then you have another LLM doing something else. It might be the same LLM, but with a different prompt. And then again, you have some other key steps where you have more LLMs, and then you get your output. And maybe this should kind of have a drawing here. This is how you build a good architecture. This is how a good AI engineer will look to build real-world practical solutions. Not funny things, not things that sound cool. A lot of times what I hear, I can't believe it. I heard this from like a PhD in computer science or machine learning engineering or something like that. He did not want to go to this. He mentioned it kind of like in some interview. He briefly his brain kind of went here, and he immediately pulled back and he said that's not interesting. They want the nerds, and I'm a nerd as well. They want the LLM to be the solution because it's more interesting, and it's more spectacular, and it's more cool. Well, good luck, because the ability to solve certain problems this way is going to be, if it's possible, is going to be many orders of magnitude more challenging, more work more expense. And we're not talking a little bit, we're talking a huge difference. Versus solving something like this, you can get a much better solution. Okay, also, because you're integrating this into your organization, collaboration is required, which means education is also important. You need to educate your team on how, on what's happening here so that they don't balk or so that they can help support this. It's not just going to be the AI engineer's job to make sure that they have everything, because I've talked to some organizations and sometimes, I'm like, hey, in order to solve this problem, we need this. And somebody to say, no, we don't need that. You can do it this way. And it's like, well, no, that's not how LLMs work. We need this. And to just get really strong pushback on that doesn't really make sense. So a certain amount of training for non-AI engineers is going to be important. You do get the benefit of getting some of the more broad benefits of just kind of using a chatbot. There's a lot of knowledge work benefits from chatbots that don't have to be put into custom AI solutions with this training. And machine learning engineering is not required for this training. And again, they don't have to be an AI engineer, but I think it's important for the people who the AI engineers need to work with to have some amount of understanding. And that would be around the fundamentals of how LLMs work. So the training, basic ideas of the training, I think is a little bit less important to know than especially how the inference works, which is basically when you call the model that it's inferring what's happening next. So that's inference. Then that's going to be really important for them to understand why the requests are happening from the AI engineer that they're happening. It's going to speed up that process quite a bit. Now, for our clients, we do have organizational training where there's a core training set, and we do recorded one-on-one consultations with somebody so that we go in and I'll talk to them and I'll talk to them about their job and identify some of the opportunities either within their own personal job or within their immediate organizational vicinity, and we record that and you guys get that. So that's something that I think adds a lot of value to an organization. Now so how do you evaluate the solution? This is very challenging. First of all, it's evolving. It's highly contextual. And again, back to education, there's a very big lack of understanding of what's really happening here. But there's some amount that you can do, especially if you're trying to automate a process or increase productivity. You can prepare by doing some initial studies on what's really happening so that you can do sort of a before and after. I realize that this is very challenging in a lot of organizations and it can be very expensive to even do this, but some amount of this could be helpful. So you'd be looking for, I think just in general, the areas look for productivity impacts for specific people. Do they do more or with less time? Or is something automated? Are there systems impacts? So when you're trying to use the model, is there something else where there's actually a cost somewhere else in the organization? Or sometimes even a downstream benefit. So there's kind of can be both. And I'm not saying AI or every LLM solution is going to benefit the organization. So being able to measure that on a more holistic level is actually very important. And then products and service impacts. We are working with a client right now where their product just doesn't cut the mustard with regards to what it needs to do. And so we're helping them dramatically improve the reliability of the product. It works half the time, and we think we can take that 50% up to about 90% using some of the stuff we know on how to use LLMs as tools within the process. And then yes, there is a little bit of just kind of putting your finger in the air and trying to estimate what happened. And there's going to be some of this that happens no matter what. But as you do the education, as you build the organization muscle, this will get better and better and easier, all of these things. So hopefully that was helpful. Let me know what you think, and contact us today for a free custom AI implementation roadmap. You can give this number a call, or you can click the link in the description, and we'll go from there. Thanks. Have a great day. Bye.